One of the main reasons why large language models are so powerful compared to the traditional machine learning is because we can train them at runtime. This technique is called prompting and is used in large language models to guide the model's output. The prompt is the initial input given to the model that provides it with context or instructions for what it should do. For example, translate the following English text to Arabic and summarize the following article are prompts. Prompt engineering refers to the process of crafting effective prompts to guide the model's behavior. The aim is to create prompts that lead the model to provide the most desirable output. The benefit of prompt tuning are reducing the amount of data required for the model to converge during training. And even cooler, the ability to reuse completely frozen language model for new tasks without retraining or fully fine-tuning. This diagram shows the prompt tuning. We start with the foundation model with a small instruct dataset. Then we add the context, which is the prompt tuning, and then we get the specialized large language model. And now I will show you how to prompt tune a smaller variant of the Bloom's model from Big Science. I performed parameter efficient fine-tuning, PEFT, which reduces the memory requirements by determining which model parameters need changing the most. Here, the packages or dependencies we need. We need BEFT, transformers, and of course torch. Then here the function to process the text, and each input becomes something like the text. For example, this movie was great, then the label. So this is the steps to just pre-process the text. Then we concatenate the input with the label. This line of code, we add this -100 to tell PyTorch ignore these tokens in loss calculation. This is how GPT learns to predict the label only. And this is the attention mask. Every real token gets attention. And this is to have the left pad to have the maximum length of the token. Then converting to tensors and truncating. Finally, we return the final patch. And then you need to clone the Raft repo to get the dataset. And this is to have the accessibility to the Google Colab. Then the model prompt tuning, defining the training parameters and the environment configuration. This is the text column from the dataset. Once you download the dataset, you will have this train.csv file with tweet text column and the label column, and this is the ID. And here prompt tuning config to define the prompt tuning config. And notice that we are using the task type .causal _lm because this is the task to predict the next token given all previous tokens. And here, this is the virtual tokens are initialized from the text, classify if the tweet is a complaint or not. Then this is the checkpoint to save or load prompt weights. This is the dataset. It is CSV file, and this is the path for the train.csv and the test and label.csv file. And this is just to print and you see the output of the dataset. Here we are loading the tokenizer. Then runs tokenizer across dataset and pre-process. Then we prepare the data loader, as you can see here. Then load the foundation model. And here we are freezing the base model and adding the virtual prompt embeddings. And only prompt vectors are trainable using this piece of code. And then the line of code to define the optimizer, only prompt embeddings are trained here. Then if you run the cell, and of course you need to save the model, so creates model directory to save. Finally, build inference prompt. So this is the phrase of the inference. You will notice that train examples 50 and the columns are tweet text label ID, and this is the first example with the text. No, this is my first job, the label, no complaint. This is the trainable params, 8192, and this is the all params. You can play with the code and see how the output will be. The main difference between fine-tuning code and prompting code is simply prepending a prompt with some sort of instruction to the beginning of each input. Prompt tuning has emerged as a powerful technique for fine-tuning large language models to specific tasks and domains. By tailoring prompts to the desired output and optimizing them for improved performance, we can make our models more versatile and effective. However, as our LLMs continue to grow in scale and complexity, it becomes increasingly challenging to effectively fine-tune them on specific tasks. This is where knowledge distillation comes to play. And the next video, I'll talk about how we can combine knowledge distillation with prompt tuning to have better output.